So it's Rails 8.1. I use Hotwire actually for the streaming, which is also what I use for the chat UI in Ruby LLM. And I found it to be very easy to use, very integrated with Rails, as Rails is in general. The only difference actually from vanilla Rails is what I use for background jobs, because I use a combination of solid queue and async job. So I use solid queue for the recurring jobs, and then async job for all of the LLM jobs and anything that calls an API, including like, sending emails and stuff like that. And the reason is that, well, with solid queue, you have a maximum number of workers, and this maximum number of workers, these workers, when they're all LLM chats and, streaming tokens in the background, they're really not doing anything else than simply like, waiting from a WebSocket. So it is kind of like using too many of your resources for not so much benefit. Instead, we have a beautiful ecosystem of async gems actually in Ruby. And if people are familiar with Python and async.io, for example, or async await keywords in, for example, JavaScript and Node.js, they know what I'm talking about. So in Ruby, we don't need to specify async and await, inside our code. In Ruby, we can simply write Ruby code just as before, but then whenever it yields at I/O, the Ruby interpreter knows already, and it will actually yield to the next fiber. This is how we call them in Ruby. Each single concurrent, piece of software.
Yeah, it's
not a thread.
better than threads, a Ruby approach, I call it. Yeah, because it's not threads. Yes, it's
exactly.
Thing, yeah.
So a thread has a different context. So it needs to save its entire context from the CPU in memory, so that it can switch between threads because they're preemptible, right? So it means that the kernel can actually say, enough, now you switch to this other thread, right? And that's how you keep this, facade of like everything is working at the same time, right? In maybe even a single core CPU, right? Otherwise, you will need to wait for one thing to finish and then another thing. And so the kernel does that in order to have this, fake parallelism.
Right.
If it has only one core. If it has multiple cores, it's true parallelism, but not in Ruby, because we have the global interpreter lock in Ruby. And therefore, even like it doesn't fully use the amount of cores and CPUs that you have on your CPU. So how do we deal with that? Well, threads are still okay in general for doing network calls because they're still preemptible. So the kernel actually switches between all the Ruby threads and everything works fine. But fibers are a lot more efficient. So there is quite a gigantic speed up in terms of context switch efficiency, the shared memory, not RAM necessarily, but the virtual memory that is used per each thread, I think is around 8 megabytes in Ruby. And for fibers, I think it's 24 kilobytes. So we're talking about completely different, orders of magnitude here. And, that translates into faster requests and a lot more throughput and all of that. But the most important part is that there is another background job processor called async job that is built on top of fibers that actually doesn't require a max worker setting. So that means that you can potentially also hurt yourself really badly in terms of the amount of fibers at the same time that you're running. But you can also set it at a very large number and still be okay because the RAM requirements are pretty low. And so the context switching happens within the Ruby process. So that's why it's really, really fast. And it is collaborative. So each single fiber needs to yield to the other fibers. But when I/O happens, Ruby is actually really good at knowing that because it knows it from the interpreter itself. And so it switches automatically to the next fiber. So it's a beautiful thing that works really, really quickly. It doesn't take much in order to switch, thanks to all the interfaces and Rails and how these things are built. So it's kind of scalability for almost free. So
Interesting.
this is the only change.